So, am I audible properly? Can somebody respond? Jebish or Santosh, anyone? Let's see. Okay, yes. So let's wait for a couple of minutes. So let people join. Then we'll start your live session for this course. Okay, let's wait for a minute. So I guess my screen is visible to you all. Can somebody respond and let me know? Okay. So it is better if we can interact with each other, be it on chat or you can unmute yourself and tell me anything, whatever you want to ask or whatever you want to interact. Should we start? Okay, so I think I should start now. So we have 2 hours, and we will be discussing on the course of non-conventional energy resources. So this is the NPTEL course we have opted, and these are live sessions. So in these live sessions, some related problems will be solved, and the content related to the course will be discussed. So basically, this is primarily focused on the interaction between teacher and students, because I guess in the NPTEL course you are watching the recorded courses, because this is the rerun of the previous NPTEL course. So the main interaction will be done through these live sessions only. So this is the non-conventional energy resources course. This course is taught by Professor Prathap Haridoss from the IIT Madras, and I will be taking the live sessions for upcoming, I guess, 14 weeks. So this is the week 1 of our live session. So as an introduction of myself, I am Lalit Bharti, and I am a Prime Minister Research Fellow, PhD scholar in the Department of Physics at IIT Kharagpur. And these are my email and LinkedIn. So if any of you want to contact me, you can contact me over there. And these classes also will be recorded and will be uploaded on the YouTube channel. So if anybody misses any classes, so you can go on the YouTube, and also you can refer your friends who are not able to attend the classes at the right time. So they can attend the classes from the YouTube itself. So all the links will be provided to you, and these PPTs will be shared to you. So you can anytime you can look at and look at them. So my field of work is basically related to this course itself. So we work on the energy storage systems, and I am basically working on the energy storage system batteries beyond lithium ion. So anybody is interested, they can interact during this course, during these live sessions, and we can have a chat anytime. So this course is for the week 1 lectures. So week 1 lectures basically covered these three broad topics. The topics are renewable energy technology, energy uses by humans, the estimate of impact on atmosphere, and third is the conventional source of energy. So the transcripts are also available on the NPTEL website. You can download also, and the courses, the videos are also available. You can always watch the videos. So basically, we'll in this live session we will discuss on the week 1 topics. So I have few questions. These are basically the old questions. One second. So these are basically the old assignment questions or the quiz questions which were taken from the previous NPTEL, the previous run of this course itself. So these are important for the course itself, and the incoming exam of this course. So we will discussing those questions. So those questions will basically clear your fundamentals, and this they will cover all these topics of the course. So let us start. Yeah. So this course basically the one term, the renewable. So the whole course is on the renewable energy system sources. So if anybody actually interested to discuss about anything about renewable energy technologies, what is renewable, and why it's useful, or why it's so important in our life, and why people are frequently talking about renewable energies nowadays. So I guess we have a little less audience. If somebody is having any issue in joining or just logging in, you can let me know. Just interrupt me in between, and I will just let them in. Okay. So renewable energy sources are basically, if we go for a simple definition, these are basically the sources which can renew themselves by themselves. So if you look for the conventional energy sources like petroleum, coke, or the natural gases available, so these sources are cannot renewed at the human scale. So if they vanish after like 100 or 200 years, or within the 100 years, so then they cannot be used again as any energy sources. But the renewable energy sources, which are like solar energy sources, like wind energy, these are these will be available this more than the time of the human life scale. So if you look for the broad scale, they will not vanish. So basically, these are the renewable energy sources. So main sources we use are solar, the wind power, and geothermal, the hydrothermal, and we can take the advantages of their sustainability, but still they have some issues. So the main issue for renewable energy sources are their intermittency. So what do you understand by the intermittency? So these sources are intermittent in nature. Like if you have supply of some energy or some power at some time, it will not be constant for the whole time scale. So basically, if you talk about, like, for example, for solar energy, so if you are getting some energy during the sunlight, you will not get the same energy, same amount of energy or same amount of power in the night time. Similarly, for the wind energy, if one day is a very windy day, so you can get much more power than compared to any normal day when the winds are not so high. So basically, this intermittent nature of renewable energy sources and energy security attached with this renewable energy sources is a big issue. So there are solution to deal with these issues. So basically, if you can, these are the energy storage systems. So if we can store energy in when the supply is high, then we can use that stored energy when the demand is high. So basically, this energy storage system can give a balance between supply and demand. So these are very helpful and very useful for the renewable energy sources. So these are some questions. Basically, we will deal with these questions. These questions are from the previous assignment. So the question says, modern oil wells have been around for less than 200 years. So if we go to the lectures and these videos and these scripts, you will find this kind of table. So this table is basically the timeline of from the age of Earth uh, to the available energy sources and whole timeline from 4.5 billion years to the present time. So this is 2017. This is basically referred as the present time scale, present time, and in which if you look for the oil wells part, the first oil well was found around 1859. So this is the first modern oil well. So if we look for this time from 2017 or from 2023, we will find these oil wells are basically just around this less than 200 years old. So we will give this answer as true. So basically, this will be true. So these kind of questions are easy, but as this is the first class, so we'll start with the very basic questions, very basic problems. Then, as the course run towards more details of the subject, then the level of questions and the the subject, the understanding of subject will increase by the time. So this was the first question. So these are assignment questions. Also, these kind of questions are also occurred in the uh, exam, NPTEL exam. So this can be helpful for you also in your exams. So the second question, these are basically the assignment questions. So in modern cities, most people are carrying solar power devices. So we can see the solar power devices like basically this is a solar panel and these are various applications which are running with the solar power. So, and this is basically a prototype car which is running by the solar power. But the question says most people are carrying solar power devices. But if you can see these devices are not portable, so you can't carry like your mobile phones. So these are not as mobile or as portable as other carryable devices. So for this question, we will give the statement false because nowadays we can't carry much of the solar power devices. Now the technologies are coming like lightweight solar panels and lightweight devices. They are coming in the market, but still they are not in everybody's hands. So we can say yes, the solar technology is everywhere, but we are not carrying the solar technology. So the third question is, at the present rate of uses of energy without changing the source of energy, it is likely that amount of carbon dioxide in the atmosphere will double in less than 100 years. So for that, we need to estimate the amount of CO2 present in the atmosphere in next 100 years. So at the left side, you can see this is the chart of world energy consumption scenario. Like what will be the energy consumption in upcoming years up to 2100, and if it shows if the population is the medium population grows with the medium growth rate, so it is going to be reaching about 30,000 million to per annum. And if the population goes with low increase rate, then it can be slightly lower, still 20,000 million toes per annum. Where in 2022, we stay here at 15,000 million toe per annum. So if we take this medium population forecast and we see the global monthly mean CO2 uh, emission by this chart from 1980 to 2020, we can see it is increasing at a very fast rate. So if we combine these two data, the energy consumption and the global energy emissions, so if we don't change the energy sources and if we stick for the conventional, this is basically for the conventional, because till now most of our energy is supplied from the conventional energy sources. So if we go with the conventional energy sources and the population and the energy demand grows in this fashion, then we will cross the mark of level of double CO2 or the double carbon dioxide emissions in less than 100 years. So basically, this statement will be true. And yes, this is a question. Um, like laser used for surgery are often on for only a very small fraction of a second of a time. So it can be true or false, but basically we have to see which kind of lasers we are talking. So for the surgery purpose or for the medical purpose, like one application is LASIK, we have to use the femtosecond laser. So why femtosecond laser? So this laser has time period of 10 to the power minus 15 seconds. So you can estimate from the name itself. Femto means 10 to the power minus 15. So the time scale is time period or the time period is around 10 to the power minus 15 seconds. So because these are ultra short pulse laser, so these are very optimized and this will affect a very certain area of your skin or of any tissue which is required. So if you want to uh, heat up any tissue or if you want to damage a tissue, a required tissue only, or any kind of treatment from LASIK to cancer treatment, if you want to kill a particular cell or tissue, you need a very sharp tool. So basically, these ultra short lasers provide you a very sharp point of your interest. So instead of your normal or the nanosecond laser, which have higher time period, so they can produce more damage to the nearer cells or nearer tissues, and they will impose microcracks and heat effects in the cells during the surgery. So this is the reason why the femtosecond lasers are used during the surgery, and LASIK is a very good example of that that application. So yes, true. So we will use a small fraction of second of a time the laser. So basically that is femtosecond laser. The next question is artificial pacemaker typically use lead acid batteries. So first, what is pacemaker? So pacemaker is a device nowadays, this short device or small device, so which is implanted near your heart, and the connection or the electrode leads goes into the heart up to this function. So basically, this pacemaker detect your heartbeat pace, and whenever needed, it will provide some impulse or some electrical signal to your heart, so your heart can beat properly. So it is required for some critical medical conditions. So our purpose is, or our statement is, does these pacemaker use lead acid batteries? But as for the lead acid batteries, we know the lead acid batteries are typically the heavy batteries, which yes, for here you can see the lead acid batteries. They are rated to 12 volt and 600 amps. So these are in kilowatt range. But in pacemaker, we require the energy of around few microwatts, and this battery should be very portable. So this is false that we can't use the typical lead acid batteries in pacemaker because they are so bulky, and they will not provide the optimum power. But these are mostly used on automobiles and at energy storage at your home, like with integrated with your solar panels. So the next question. So we need to match the following devices and their power users capabilities. So there at the left sides we have five options: the car battery, household bulb, Hubble, submarines, and pacemaker. So car batteries, we know this car battery is around 12 volt at 600 amperes. So if we calculate its energy density in wattage, so it will be around 72 kilowatt, 7.2. So basically, our car battery will lie in the range of 5 kilowatt. Similarly, our household bulb. So as we know, this typical household bulb can be of 100 watts. So nowadays we are having light bulbs with much lower power rating. But this is a typical example. So we need to go for zero point 0.1 kilowatt. And Hubble is at the left, the rightmost. This is the Hubble telescope. So this is basically a telescope in the in the space. So this is taking pictures from the space. So, and although it is very large in size, but it is still very power efficient because it completely runs on the solar power, and it's working from many years. So so we can estimate the Hubble is the 2.4 into power 3 watt. So it can be 2.4 kilowatt. So this summary of the users, this table is already taken from your course, your videos or your transcripts. So you can refer to your material, your videos to get this kind of table. Similarly, submarine and pacemaker. So pacemaker, as we know, it needs the power of in the range of microwatts. So the pacemaker goes to the first option, and submarine to the 1 megawatt. So for this, basically our answer B will be the correct option. Okay. Yeah. So this is the next problem. So these are basically the previous year quiz questions. So these are important for your next quiz also, and similarly for your upcoming exams also. So this question states to arrange the following gases gases in the increasing order of their volume percentage in dry air. So it is basically their presence in the atmosphere. So from the pie chart also, we can see and we know that most of the atmosphere is made up of nitrogen. So 78% is nitrogen. Then the second, the amount of gas is oxygen, and then other gases. So in other gases, also from this table, we can look for their percentage by volume. So first is the nitrogen, second is oxygen, third is argon, then comes CO2, then comes neon, helium, and methane. Methane is very low in percentage, but yes, it is there. So if we try to arrange these gases, we will see the answer 3 is the correct option. Okay. So the next problem is, yes, meteor burning of generally occurs in blank, and the jets liner fly in blank space. So basically, we need to put the correct options in the blank spaces. So in this picture, at the left side or right side, you can see the structure of Earth's atmosphere. So we can see the nearest layer of atmosphere to the Earth, that is called the troposphere. So this is the layer, or this is the part of atmosphere where we live, where the normal planes or jets fly, and where all these atmosphere, these seasons, these clouds are formed. Okay. So in the first option, it is the troposphere. Yes. So first they are asking the meteors burning. So meteors burning in which space? So you can see from this both images, from the right image also, these are the meteors. They are coming from space, and at this space, from height of 50 to 80 meters, they are burning, and we can see them lightning in the sky at the night time. So these are basically happens in the mesosphere, and our planes or jet liners are flying in the troposphere. So basically, the correct option is mesosphere at the first place and the troposphere at the second place. So the next problem is, approximately 80% of Earth's atmosphere's mass is in what? So we know the troposphere is the nearest level of atmosphere to the Earth, and this is the layer where most of our air is present. So 80% part of our atmosphere, the 80% mass lies in this troposphere only. Due to the gravity of Earth, all the gases and all the particles present in the atmosphere, they are present in the troposphere only. So the correct answer is the troposphere. So the next problem is time required to double the CO2 in the atmosphere at the present rate of usage in years, and it is calculated based on the assumption of these two statements. First is the whole atmosphere is within the troposphere, and second one is all energy released is through carbon combustion. So from your class notes or from your video lectures, you will know. So if we calculate the amount or the number of years in which the CO2 will be get doubled is around 86 years. So this will be 86 years, and for these two statements, first in all atmosphere is within the troposphere. So from our previous question also, we know that most of the mass of atmosphere lies in the troposphere only. And second is all energy released is through carbon combustion. So as we know, this is the CO2, the main generation or the main cause of forming CO2 is our combustions, be it be in the vehicles, be it be in the industry. So the main reason or main source of CO2 production is carbon combustion. Carbon combustions basically represent here the reaction of carbon to oxygen or the burning of oxygen, burning of carbon. So after burning, it will provide you or it will produce carbon dioxide or CO2. So we can see these both statements are correct. So our option second is correct. Let me take people in. Okay. So this is the question, next question, which asks for find out the genuineness of below given statements. So for both statement, you have to see the first statement is enthalpy change for the formation of carbon dioxide is an endothermic process. So what is endothermic process and what is exothermic process? First, we have to see this. So exothermic process are at the first this endothermic process are where by the interaction of ingredients or the reactants with the product, the energy released is negative or the energy is absorbed in the or the energy is absorbed during the process. And exothermic processes are where the energy is released during the process. So here we can see burning of a match or it represents burning. So burning is where a lot of energy is released. So this is basically the exothermic process. Now we have to see the statement, the formation of carbon dioxide. So basically the simplest interaction or simplest reaction we can see can be carbon reacting with oxygen with some temperature, because we need some temperature to make them react with each other, and we will get CO2 and energy. So once it creates energy or emits some energy, it is called exothermic reaction. So this statement is not correct because the formation of carbon dioxide is not endothermic, it is exothermic. And similarly, the enthalpy part. So what is enthalpy? So enthalpy, simply you can understand that this is the amount of heat evolved or absorbed in the reaction carried out at a constant pressure. So if the process is exothermic, so this enthalpy change or delta H will be negative because it is the amount of heat evolved or absorbed. So in this case, it is getting evolved. Heat is getting evolved. So the process is exothermic, and the enthalpy change delta H is negative. Similarly, in the opposite fashion, for endothermic reactions, the delta H is positive. So first statement, the enthalpy change, so it will be negative for the case of CO2 formation. And the second statement is enthalpy change for the formation is carbon dioxide is 394 kilojoule per mole. So from your lectures, you can check the calculation part, like how they have calculated the 394 kilojoule per mole. But the most important point to be noted is it is 394, not the negative 394, because the change of enthalpy should be negative. So we will see this statement will also be false because the delta H for this formation is negative of 394 kilojoule per mole. So the both statements are false. And this next question is crude oil contains which elements? So crude oil is basically the petroleum product we get from the earth crust, or the not the earth crust, from the earth. So the crude oil is basically the hydrocarbons. These are the hydrocarbons. So hydrocarbons, these are basically made up of carbon, hydrogen. So carbon and hydrogen are the main two components. But we can see these are not limited to carbon and hydrogen. Although carbon is 80 to 85%, hydrogen is 10 to 14%, and other parts are very low in amount. But these are present: so nitrogen, oxygen, sulfur, and some very few 0.1% some metals. So yes, all these elements will be present in the crude oil. So the next question is, these are the quiz questions of previous NPTEL course. So you can expect these in your upcoming quiz, which will be graded, and the upcoming exam, which will decide your grades, the final grades at the end of the exam. So these kind of questions can be important. So this next question is, in the world energy uses, this pie chart, it is seen that most of the energy currently used by humans comes from, so which energy? So we can see this is the pie chart. So this green part is renewable energy sources, and this whole rest of this green, these are basically the non-renewable or conventional energy sources. conventional sources. So from this course, these sources also we can see most of the part is covered with natural gas, petroleum, and coal. So all these three comes or lies in the fossil fuels. So our answer for this question will be fossil fuels. So this question is for to realize people or the students that what is the need of renewable energy sources in present scenarios and for the future, because you can see only 11% is renewable energy, rest of is the conventional or the non-renewable energy sources. So we need to deal with this and we need to increase the percentage of renewable energy in our main energy consumption. So the next question is conditions under which crude oil forms are millions of years with which. So crude oil is basically in this picture you can see the formation of crude oil. So at this left image, first you can see at the water body or the at the uh, in the water or in the sea, at the bottom of the sea, you can see there are some dead organisms, plants and animals. So basically, these plants or these animals, these are all organic compounds. So if they trap in the in the bottom or in the belt of the sea, so all sedimentary rocks or rocks will cover them. And after years and years, after millions of years, these rocks will provide very huge pressure and very huge temperatures to the trapped fossils. So basically, what will happen? They will feel very high temperature and very high pressure. And with this pressure and temperature and added with years of time, they will convert into this oil, gases, or coal. And in the right picture, you can see how these resources are extracted. These are basically the wells. It can be gas wells or it can be oil wells, depending on the depth or the level of resources available. So we can say that we need high heat plus high temperature. But the thing is, they should not interact with the oxygen, because at the when they are trapped inside the bottom of the earth or bottom of the sea or the in the in deep below the rocks, they will not get enough oxygen, and then only they will convert into the coal, oil, or other energy sources or the energy products. So basically, these will be produced or these will be formed in the absence of oxygen. So our option one is correct. So basically, these were few questions, and yes. So these were few questions depending on and based on the first week of the course, and we have pretty much time. So if you have any questions, we can interact, and you can ask me any kind of questions related to this course or this topic. Uh, it can be any based on your research program, or it can be anything. So I am still here. So if any one of you have any doubts in these questions or in this course or related to this topic, You can either write it in chat or you can just unmute yourself and you can just interact and we will try to find it out. So yes, this is the first class. I have kept it brief and this all the questions covered are the basic questions from the first week assignments only. In the next class, we will, as the course proceed, we will take the problems uh, much more deeper in the subject area. So we will take a break of 5 minutes. Then these questions parts are done. So for the upcoming 1 hour, we will be discussing the only transcripts or the course content which is taught online during the classes. So after 5 minutes, so at 8 p.m. sharp, we'll again start the classes. Okay, so we'll start the class again. So from the transcript, this is the transcript or the book for the this course. So we are at this week one. So the week one, okay, so we will start from the lecture one. Week one has three lectures. So we'll start from this first lecture. So this is basically the renewable energy technologies. This is completely the introduction. One second, I will just set it up again. I hope my screen is visible. Okay, so yes, from the week one. So these are our lecture transcript. So the first thing you can understand is the scale of quantities. So these are basically just simple introduction of scales. The scale lies from femto to iota. So femto stands for the 10 to the minus 15. Then comes pico, nano, micro, milli. These are the standard kilo, mega, giga, tera, peta, as we know. Exa 10 to the power 18, zeta is 21, iota is 10 to the power 24. So these are units, basically, these are used while talking about the energy and energy consumption and uses, the data stores like this gigatera is commonly used for the data stored in between your hard disk or your any data storage device. Here we come for the femtosecond laser again. So here it is shown the advantage of femtosecond laser. Like if some laser with some higher time period or is used, like if nanosecond laser is used, the affected area or affected volume of the skin or of any tissue will be much larger than the than when we use the femtosecond lasers. So it is very preferred when you use femtosecond laser in surgeries or in fabrication of any kind of devices is nanoscale, or when you need very good precision, the femtosecond lasers are widely used. So we saw the question also in the surgery which laser is used. So that is lithium 2 second laser. Then it comes with so similarly for the resolution or for the size, if we want to see the microstructures, so if we go up to 10 to the minus 6 or nano is 10 to the minus 9 meters of scale. So we need some microscopes, basically some optical microscope, and so the optical microscope can give you the resolution of some microns. So this is shown a uh, basic lab optical microscope. So its resolution is in range of micron or micrometer. So the another unit in this micro range is the use of artificial pacemaker. So these pacemakers they run at the power of 60 microwatts. So it is 10 to the minus 6 watts. So they use lithium iodine batteries and which have the life cycle of 5 to 10 years. So these are basically non-rechargeable batteries. Initially, at the first, when the pacemakers were used, this nickel cadmium cells were used. They were rechargeable, but the main issue was their limited life cycle. So if we need to recharge them rapidly in these again and again, so it can be a major issue, especially for the case of medical equipments, sensitive medical equipments like artificial pacemakers. So nowadays, lithium iodine batteries are used, which have very good battery life, and we don't need to recharge them. They will just run up to 10 years. Similarly, for the unit of milli, so we have this milliwatt power source. This is scientific calculator. So this kind of calculators runs on the power rating of zero point 0.1 milliwatt. And for the example of if you like to convert this power, so these triple double A batteries, these capacities are 3 watt hour. So basically the capacity tells you if this 3 watt hour means this battery can give you a power of 3 watt for 1 hour. Otherwise, 1 watt for 3 hours. So basically, these are these representing the capacity of batteries. Similarly, this is the range of 10 to the power 0. 10 to the power 0 means range of 1. So our cameras the cameras use the battery which have the power rating of 3 watt, and they have the capacity of 14 watt hour. So these are the typical batteries used in cameras. So if it is 3 watt battery and capacity is 14 watt hour, you can divide the 14 watt hour with 3. So it will run for 3, 4 and 4 plus hours. So these are the basic batteries, and this is the test power 0 domain. So if we go up to test power 2 or range of hundreds, so some examples are household bulbs, tube lights, and other electrical equipments. So they are basically working on the 5 watt to 200 watt. So these are test power 2 watt range of uh, power. So, and if we go more, so this is 10 to the power 3 watt. So basically, these are in the range of kilowatt. So if you 10 to the power 3 watt. So this is the example of Hubble telescope. So Hubble telescope, as from the previous questions we discussed, this is the telescope moving around in space, taking pictures from space of various objects. It runs on the solar power and it has its own battery pack. So they store the energy when it is away from sun or not in the direction of sun. So it have 36 meter squares of solar panel and it is backed up with 6 lithium hydrogen rechargeable batteries. So the capacity of these batteries or the power uses of this Hubble telescope is 2.4 kilowatt or 2400 watt. So this is example of 10 to the power 3 range. And if we go for 10 to the power 3 more other examples, so batteries in our cars, they are equipped with the 5000 watt uh, capacity of uh, batteries. So these are basically lead acid batteries. There's capacity of 600 watt hour, and they can provide the power of 5000 watt. So because in the for starting a car, we need a very high amount of power to drive the starting motor. So that's why the high power batteries are used. These are lead acid batteries. These are bulky compared to lithium or this other previously top system, but they are pretty much used in automobile sector and other home applications. Similarly, this is stands for 4 range. This for this larger vehicle, the power usage is 20 kilowatts, so the battery capacity used is 30 kilowatt hour. You can divide the battery capacity by power users and you will get to know how many hours it can run uh, with this battery. So 30 by 20, then you will get the amount of hours. Similarly, other examples of transport 4 range. So transport 6, we see these are example of submarines. They use the power rating of 500 kilowatt to 3 megawatts, depending upon the size of submarine. So this is the example transport 6 watt application. Now for another example of transport 6, we can see this camera. So basically you have everyone has heard about cameras and we store pictures in megapixels. So mega is basically transport 6. So each picture, whenever you take a single picture, it is divided into pixels So the number of pixels, and each pixel will be converted in a single data point. And whenever you need to see the picture again, the all the data points will convert back, and each data point will give you a single pixel. Then after merging all the pixels, you will get the whole picture. So the more number of pixels, the more resolution of your picture will, or your image you will get. So this is the example of the transport 6 or the uh, mega range of example. Similarly, in the mobile phones, nowadays we are frequently using this term GB or gigabytes. These are basically GB. In giga means stands for 9. Also, the data is stored in the unit of bytes. So if the data is stands for 9 bytes, then it is called GBs. So more it comes with like hard disk. So they comes in the range of TB or terabytes. So this is 10 to the power 12 bytes of data. Then it is stands for 15, which is called PETA. So PETA is a good example of PETA is supercomputers. Like supercomputers works with 10 speed of 10s or 100s of PETA flops. So one flop as a flopping point, it represents operation, a single operation. So if transfer 15 floating point operations per second are executed, so that's called petaflops. So this represents the speed of supercomputers. So this is example of 10 to the power 15. Then the example of exa is 10 to the power 18. So the world energy uses, these are basically measured in exajoules. Similarly, comes with tau. So the exajoules are the 500 exajoules are the world energy uses per year. This picture this represents that the humidity is said to have crossed 1 zettabyte mark in terms of data created and stored overall. So zettabyte means stands for 21 bytes. So 21. So humidity till 2010, the humidity or all humans have created 10 to the power 21 bytes of data. And in 2022, it's already much more higher than that. So this is example of range for 14, range for 24. So this is a NGC, this is a galaxy, distance is estimated 100 million light years. Again, for the comparison, this is chart from Femco Toyota. And this is the example of all instruments or all the applications from pacemaker to submarines, from microwatts to kilo or megawatts, and the energy stored in the respective energy in the respective application of energy storage. So, renewable energy technologies. So in the lecture two is the energy uses by human and estimate the impact on the atmosphere. So basically we will find how much energy is used by humans and what was the impact of this energy used on the atmosphere. So as it has already shown, the world energy uses per year is 500 exajoules. components from nitrogen to oxygen and all other gases present in the atmosphere. And this slides come with the layers of atmosphere. So the nearest layer is called troposphere, as we already discussed in the previous questions. This is the layer where all the planes, aeroplanes, and the jets, jetliners, they fly. This is the this is the layer which is closest to the Earth, which is most dense due to the gravity of Earth. So it is the almost all the mass of our atmosphere is covered, or the 80% of our atmosphere is in the troposphere. Then come the stratosphere, mesosphere. Mesosphere is the part where the asteroids are seen burning. Then thermosphere and exosphere is the last layer. It is around 700 to 10,000 kilometer far, and this is the range of this layer. Here, the volume of troposphere and volume of CO2, the carbon dioxide is calculated, and the ratios of carbon dioxide is calculated, and composition. Yes, here it is the composition of carbon and crude oil. So in crude oils are basically the hydrocarbons. So these are the 83 to 85%. Carbon is present in crude oils. Other than that, the main component is hydrogen. Then comes nitrogen, oxygen. Sulfur is some very rare, very few metals. So the combustion of carbon is shown here. So the enthalpy or the delta change in enthalpy is calculated to be negative of 394 kilojoule per mole. So it is negative because it is exothermic process. And this was also discussed in the questions. So here it is again calculated that 5 into 10 per 20 joules of energy is correspond to release of 2.8 into 10 per 13 meter cube of CO carbon dioxide. So this is the volume corresponding to this much of amount of energy. So here the calculation for our question, that how much time it will take to double the level of CO2 in atmosphere at the present rate of uses. So it is calculated to be 86 years. So in this lecture, it was calculated that concluded that energy usage is significantly high for humans, and it is significantly impacting the composition of atmosphere. It is increasing the level of carbon dioxide in the atmosphere in the very short period of time. So as we come on the lecture 3, so this is basically lecture conventional source of energy. So again, the conventional and non-conventional. Conventional sources are the traditional sources we have been used for energy, like burning coke, petrol, petroleum products, natural gases. These are the all the conventional source of energy. So it is shown the age of Earth is 4.5 billion years. Then dinosaurs. Then our first well was found in 1859. Now, in 2017, the global oil production is nearly 100 million barrels a day. So this is the this picture, this image shows the production of or the formation of crude oil. So basically, it is shown that first at the seabed, dead plants and animals, they are uh, they are present at seabed, and all the mud and other sediments, they are deposited on the dead plants and animals. So they are basically trapped on the rocks, below the rocks. This eventually, by the millions of years of time, these rocks put a lot of pressure, a very high pressure on the dead plants and animals. So, on the trapped plants and animals. So, with the immense heat, immense pressure, absence of oxygen, and millions of years of time, they get converted into the crude oil or the petroleum products. So that is why most of the oil resources or the crude oil resources or petroleum resources are near the sea or where the sea was uh, there in the past time. So as the impact on environment, so yes, these things or these emissions or these production of carbon dioxide, they have changed the composition of our environment and atmosphere in very significantly past 100 years. So this is basically a big motivation to move towards renewable energy sources, because if we move without renewable energy sources with conventional energy sources in the same manner, it will be very much more impactful and it will harm our atmosphere. So we need to move from the fossil fuels, because at this time almost 80% of humanity depends on the conventional energy sources or the that comes from the fossil fuels. So we need to move towards renewable energy sources, which can be hydropower, which can be other renewable energy sources, which are very few at the present time. So as we earlier shown, only 10 to 11% for in this range, the renewable energy sources were used. So as the power consumption is rapidly increasing and the GDP or uh, the growth of the country or the growth of world, these things are closely linked. And even in the especially case of India, we are developing country, so the energy consumption is going to be very high in the future. So we need to find the cleaner source of energies to save ourselves, to save our environment, to save us. So we need to move towards renewable energy sources which are clean in nature and which will not produce any adverse effect on the atmosphere. So we need to move towards renewable energy sources. So this week one or these three lectures were the basics of energy, non-conventional energy sources, why we need them, mm, just the basic recall of your units, unit range, their their applications. So from the next week, we will be moving towards the week two of live session or the lecture four. So it will include the topics on yes, it will include the topic on non-conventional sources for energy. It will be an overview, the energy consumption, the details of energy users in each sector. So we will go through towards this in next week. So by the time it's I am here. If you have any query or any doubt, you can interact with me. So I will be here, and the meeting will be running till 9. So if any kind of question and any query regarding the previous assignments or the upcoming assignments, so you can write it in chat or you can directly ask, or also you can share the queries to other contact, like you can mail me or anything like that. So Chirag, this session is going to be end now at 9 p.m. So if you have any query, any questions regarding the assignment of week one, you can ask anything. You can just unmute or you can just also write in chat box whatever your query you have. So would you like to have some interaction? Anything if you like to tell about yourself, anything you can share. Okay, so we are going to end this session. So if you are if you have any query, you can also use the comment box of YouTube. So there you can write your question. So and I will answer each and every question there. So you can write. And next session will be on this at the same time next week, and we will be discussing the week two problems, and we'll try to interact with more people. Okay, so thank you all.